Well, greetings, my little triglets. How is everyone today? All right, today we're going to finish up our last section in chapter 11, section 11.6. This is where we're going to take everything we've learned so far about all the conic sections and kind of put them all together. What we're going to do is we're going to take two different equations of different shapes and see all the possibilities for their intersections. For example, if I take a circle and a line, here's a circle and a line. It has two places of intersection, so that has two answers. This one, maybe it just hits it once right on the edge, so that would be one answer. Or it could hit it none at all, so that might be zero answers. Now, if we have our shapes, here's an ellipse and a hyperbola, so I've got 1, 2, 3, 4 answers, 4 places where they intersect. Or maybe it's something like that. So I have 1, 2, 3 answers. Or maybe there's only 2 answers, or only 1, or none at all. So we're going to get these two equations, we're going to solve them simultaneously, and the solutions we come up with are the points of intersection that work for both. Okay, so the first one we're going to do, I'm going to go to the next page here, is let's try a circle. X squared plus y squared equals 34, and we'll do a line. We'll do an easy one first. So I'm going to have you identify these. We're going to practice identifying what shapes they are. This is a circle. We talked about this because we have a plus sign and these numbers in front are the same. That's how you know it's a circle. All right, so one way to solve problems like these is to isolate and substitute. So I am going to isolate the x on the line equation. So if I add y to both sides here, I'm going to get x equals 2 plus y. Now I'm going to take that 2 plus y, which equals x, and I'm going to put it in to the circle equation for x. So I have 2 plus y squared, because that's x squared, plus y squared equals 34. Now I'm going to FOIL this. So I have 4 plus 4y plus y squared plus y squared equals 34. So this is all the foiling that came from that parentheses. Now I'm going to get my like terms together. I have 2y squares and then 4y. And I'm also going to bring over the 34 and put it with that. So I'll have negative 30 when I do that. So we set it equal to 0 in order to solve the quadratic. Now I do notice that each of these is even, so I'm going to divide them all by 2 just to make my math a little bit easier. So I end up with y squared plus 2y minus 15 equals 0. Now at this point, you know your options. You can do quadratic, or the quadratic formula, or we can try to factor. So y and y, 15 would be 3 and 5. I need a plus 2, so plus 5 minus 3. So my two answers for y are 3 and negative 5. Now I'm not finished. I need to know the point of intersection. These are just the y values. I need to find the x values. So the points, the intersecting points, so far that's what I have. Now what you have to do is back substitute, and you have to make sure it's the easier of the two equations. And that way you won't miss any answers. Now, easier means less complicated. A line is less complicated than a circle because it doesn't have any squares. So that's where you're going to put the 3 and the 5 back in. So I have x minus 3 equals 2. So add 3 to both sides. So you get 5. So that's a 5 there. Now I'm going to say x plus 5, or minus a negative, subtract 5, so I get negative 3. Now it's just coincidence that they're both 3's and 5's. It doesn't always come out that way. So if you drew a picture of these two, in fact I can do that real quick. Let's go to the next page. Let me rewrite them. X squared plus y squared equals 34, and x minus y equals 2. So drawing the picture of these, this is r squared, so the square root of that, well, if that were 36, it would be 6. So I know I'm just under 6. So I'm going to go there, 1, 2, 3, 4, 5, 6. It's not real perfect, but we'll just go with it. So that's the circle. Not too bad, if I do say so myself. So now what I'm going to do is I'm going to swap these two. So I have x minus 2 equals y. Your slope is 1 over 1, and your y-intercept is negative 2. So that's your b. Y equals mx plus b. So I'm going to go down 2, put it out, and then rise 1 over 1. And so it's going to look something like that. So the points of intersection are here and here. Now, does this one look like 5, 3? And does this one look like negative 3, negative 5? I'd say pretty close. We go over 5 and up 3, go over 3 and down 5. So that would be the picture of it, showing it. And try to draw your graphs. You can even use graph paper to help you figure that out. Okay, let's do one that's a little trickier. Let's do 2x squared minus 3y squared equals 6, and x squared plus 2y squared equals 17. Okay, first thing we're going to do is identify them. So I have different numbers, 2 and a 3, and I have a minus sign. And that makes it a hyperbola. For the next one, I have different numbers, a 1 and a 2, and a plus sign. That makes it an ellipse. Okay, so we've identified them. So now, instead of isolating, if I tried to isolate like x squared, then I'd have a y squared that I'm subbing in here, and I'd have to square it again, and I'd end up with a fourth power. I don't want to get that complicated. So instead, I'm going to try to eliminate. Okay, so elimination is a better way to do it when they're all squares. So what I'm going to do is I'm going to multiply this bottom row by negative 2. So I'm going to rewrite 2x squared minus 3y squared equals 6, and then rewrite this as negative 2x squared minus 4y squared equals negative 34. Now we can add those rows together. I eliminated the x squared, so what I have left is negative 7y squared equals negative 28. Divide, so y squared equals 4. That means y equals plus or minus 2. Okay, so plus or minus 2. So my points, I know I have a 2 and a negative 2 so far. Now looking up, we're supposed to back substitute into the easier of the two equations. Since they both have squares, one is not easier than the other, so it doesn't really matter which one you do. I'm just going to choose the top one. So if y is 2, I'll do it here. If y is 2, I have 2x squared minus, put a 2 in there, I get 4 times negative 3 is 12 equals 6. Bring the 12 over, 2x squared equals 18, x squared equals 9, x equals plus or minus 3. So I have a 3, but I have to do another one with a minus 3 and a 2, because the 2 has a plus or a minus 3, so I have to write it again. So it looks like we're going to get 4 answers, because when I do that here, negative 2, if I plug a negative 2 in, I'm still going to get the same exact result. So I'm going to get x equals plus or minus 3, because the negative is going to cancel out with squaring it. So I'm going to have another 3 and negative 3, negative 2. So those are my 4 points. And then if you need to graph to show it, you're going to have to get these into their regular form. So you would divide everything by 6 to get that to be 1. Here you divide everything by 17, and then you would draw the graphs from that point on. All right, let's try another one. And let's see if you can identify these. Oops, I don't want that. I want plus 8 equals 0. And then x squared minus 7y squared plus 4 equals 0. So, what do you see those being? I have a minus on both of them, and their numbers are different. So the minus sign is your big clue that it's a hyperbola. So both of these are hyperbolas. Now think about hyperbolas look like that. I could theoretically have another hyperbola coming like that. And how many? We got 1, 2, 3, 4, 5, 6, 7, 8 different possibilities. Now I'll tell you right now, we're not going to get 8. 4 is the most we're ever going to run into in our dealings. So, but theoretically, you could have 8 different intersecting points. All right, so we're going to do the same thing here. I'm going to multiply this whole bottom row by -2. I'm also, well, let's just go with that for right now. So I have rewriting 2x squared minus 5y plus 8. You can put the 8 on the other side. It doesn't really matter for our purposes. So negative 2x squared plus 14y squared minus 8 equals 0. So adding those up, I get that to go away. I get 9y squared. I get that to go away. Divide by 9. So y squared equals 0, so y equals 0. There is no plus or minus when it's just 0. So let's plug that back in. I'm just going to do it in the top one here because they're both squares and both hyperbolas. So 2x squared minus 0 plus 8 equals 0. So 2x squared equals negative 8. X squared equals negative 4. Now, is that possible? You can get plus or minus 2i, but we're not going to do imaginary numbers. So this basically has no solution. If you get a negative with a square, there is no real solution. And basically what it's going to look like is probably something like that. The two hyperbolas don't overlap anywhere. So, all right, those are the different things you'll run into. The two different ways. You either isolate and substitute, or you use elimination. So those are your two ways you're going to do these. And if you get a negative with the x squared, that means there is no solution. All right, that is it for notes. Ta-ta for now. Don't forget, we got some Trig love happening. All right, see ya.